Hello everybody, I am back for another math video, specifically for integrals, and as you can see I have finally updated my program. I am no longer using Microsoft Paint, thankfully, and yeah, my videos will now actually have good quality. So anyways, we're going to integrate 1 over x to the 5th plus x cubed in two ways. The first one will be partial fraction, which is the expected way because we can factor this in the way I'm about to show you. And the second way, I'll let you see that in the next video. So in this video, we'll only do partial fraction. So we could set this equal to be the integral, that is a huge integral sign, the integral of 1 over, the common factor here is x cubed, so we could factor that out. We'll get x cubed times the quantity x squared plus 1. So this is going to be a constant a divided by x, and then plus a constant b, that looks like beta, but I'll roll with it, over now x squared, plus another constant c over x cubed. And now that it reached the original degree that it had in the original integrand, we can this factor is done. And so now we'll move on to the next factor, x squared plus 1. And so now you have x squared plus 1 here. It needs to be, the numerator needs to be a degree less. So this is going to be dx plus e, a linear function. And so now we will, I'm just going to copy this over to the side here. Because for these ones, well, for this one you need to multiply by x squared on the top and bottom, so that the denominator becomes x cubed, and you also need to multiply by x squared plus 1, since you also have this factor right here on the top and bottom. And then for the b fraction here, you're going to have to multiply by just x to turn this into x cubed in the denominator here, and then by x squared plus 1 again on the top and bottom. And so now we'll need to distribute ax squared to both of these. We'll need to distribute bx to both of these. We'll need to distribute c to both of these. And we'll need to distribute x cubed to both of these. And so now, when we split this, I'm going to sort of skip a step here and just combine the fractions. So we know the denominator will be x cubed over x squared plus 1. And so now we're going to get, so let's work from left to right. So ax squared times x squared will be a times x to the 4th, and then plus, we're going to get ax squared times 1 is just a times x squared. And then for the next one, bx times x squared is bx cubed plus b times x, because bx times 1 is just bx, and then plus, now let's work on the c fraction. So we're going to get c times x squared is just cx squared plus, and then to distribute the c to the 1, you'll get plus c. And then I'll try to cram in a little bit of space here, or I'll just extend the fraction bar. X cubed times dx will be d times x to the 4th, and then plus, you're going to get e times x cubed is just e x cubed. Alright, and we want this to equal the original part, the integrand here, and so the original one was 1 over x cubed times x squared plus 1, and so these denominators will cancel out, and so now I'm going to do a little bit more simplifying. So let's combine like terms. So if you notice, for the x to the 4th terms, you have a and d as the coefficients. So we can factor x to the fourth out for both of those. So you'll get a plus d times x to the fourth. And then plus, for the x cubed terms, let me use a zigzag line for those. For the x cubed terms, this is at 2 by the way. For the x cubed terms, you're going to get b, let me write it down, you're going to get b plus e as the general coefficient for it, times x cubed, plus, and then for the x squared terms, I'll do a steeper zigzag line. And so the coefficient here for x squared will be a plus c, so again times x squared, plus, and then the only x term here is just bx, I'll circle that one. So we have plus b times x, plus, and we have a constant term, I'll just put a straight line for that one, that's just plus c. And so now that we are done with that, we can set that equal to, we only have 1 on the right side. And so now we can set a system of equations here. So the only term on the right side is 1, and c is the constant for this one, which means that c will have to equal 1. So we already have one of the 5 letters identified, that's nice. And then there is no x term on the right side, but which means that b, the coefficient of x here, will have to equal 0. So we have another one identified. And then likewise we have no x squared term on the right side here, which means that a plus c must also equal 0. Likewise there's no x cubed term, so the coefficient of x cubed, b plus e, must also equal 0. And finally there is no x to the fourth term on the right side, so the coefficient of x to the fourth, a plus d, must need to equal 0. And so now we already have two of the letters found out, so we can easily finish the rest of this system of equations here. So we know that a plus c is equal to 0. We can substitute 1 in for c, so we get a plus 1 equals 0, which means that a is equal to -1. So now we have another one solved. And then we can use the b plus e equals 0 here. We know that b is equal to 0, which means that 0 plus e equals 0, so e is also 0. Okay, so now we can do the last one. So we know that a is equal to -1, which means that a is -1 plus d is equal to 0, which means that d is just equal to +1. And so now we have all 5 of the letters solved. And so again, let's go back up to the original partial fraction split here in the integrand. So we know that a is equal to -1. We know that b is equal to 0, which means that this term will just completely wipe out here. And then we know that c is equal to 1. We know that d is also equal to 1. And we know that e is equal to 0. And so now let's take this part, move it through this big hunk of junk right here, and continue on over here. So this is the integral of now -1 over x, alright, and then plus 1 over x cubed, or I'll just write that as x to the -3, and then plus 1x, or just x, over the last factor, x squared plus 1. And we solve the differential x at the end. And so now we can integrate all 3 of these pretty easily. So the integral of -1 over x is the negative integral of 1 over x, which is just -ln, the negative natural log of the absolute value of x. And then for x to the -3, we have to use the reverse power rule. So -3 plus 1 is -2, which means we will have plus x to the -2 over -2. I'm not simplifying just yet. Plus, we'll have to do a little bit more work on this one, so I'll just move this to the side right here and make this green. So we want to find the integral of x over x squared plus 1. And so we're going to use a little bit of u substitution for this one. We'll let u equal the denominator x squared plus 1. And when we differentiate both sides, du will equal 2x dx. And so here on the numerator we have an x dx only. So we have to put a 2 in front of the x, but that changed the value of the integral. So we have to forcefully put a 1/2 in front of it so that the integral, so that the value of the integral stays the same. And so we know that 2x dx is just du. We still have the 1/2 integral at the front. We have the integral of du over x squared plus 1 is just u. And so if you're in calculus 2, you've done this integral many times. You should remember this as the back of your hand. 1/2 the natural log the absolute value of u. And so now we can move this over here since we solved that integral now. So it's going to be 1/2 the natural log the absolute value of u. And so now when we do some final simplifications, this is the same as saying this right here is the same as saying 1/2 times ln the absolute value of x squared, right? Basically, you can move the 2 to the front, and the 2 and 1/2 will cancel out, so you'll just be left with ln the absolute value of x, which is the same as we originally had. But I'll show you why we did this. So this will now be x to the -2 over -2. That will just be -1 over 2x squared for that one. I just moved that. I'm going to change the order a little bit. Hopefully you guys are fine with that. And then plus 1/2 times now ln the absolute value of u minus 1/2 ln the absolute value of x squared. And that, actually that one doesn't need an absolute value because x squared will always be positive anyways. Assuming that you plug in a real number for x. And so now we could factor out the 1/2 from this expression. So we will just be left with this right here. Okay, I actually don't know if there's an eraser tool or not, but I'm just going to scratch this out. And so, you know the logarithm rule of subtracting 2 logarithms with the same base? That's just the same as saying we still have -1 over 2x squared, and then plus 1/2 times, you're going to have the numerator over the denominator in one big ln. So you're going to have, oh, by the way, u we know is just, x squared plus 1 from that formula. So it's going to be the natural log of u, or x squared plus 1, over the one that's being subtracted, x squared. And so let's put the parentheses around that. And now we are officially done with this, so we can add the plus c at the end and box our answer. So that was the first way to integrate 1 over x to the 5th plus x cubed. You could try to mess with this a little more, like split the fraction inside this logarithm here so you get 1 over 1 plus x squared, but that doesn't really make much of a difference. It doesn't really make it much simpler, so I just like to leave it this way. Anyways, that's it for this video. I hope you all enjoyed this, the new style I'm doing. This is a lot better than Paint. I am enjoying this a lot so far. And if you'd like to see more, just let me know what you'd like to see, and I'll see if I can do it. I will post part 2 pretty soon, so look forward to that.